Hey guys, this is Gabino once again, and I'm here to talk about how to rationalize a surd, right? How do you rationalize a denominator for a surd when you have a fractions, right? So let's see how it works, right? So I've got a few examples here. Now, the first example here, as you can see, we have got 1 on the square root of 5, right? So 1 on the square root of 5. How do we rationalize the denominator? How would we rationalize the denominator? So what you do when you have when you have just a surd with this form where there's no variable in front or anything else. So what you do is you just take what you do is you take the one, you copy that number, which is 1 on 5. I'm gonna copy this, sorry, and then you times by square root of 5. You times it by root 5 on root 5. Now you may wonder why. What does this do? What this do is, first of all, let's analyze this. Square root of 5 on square root of 5 is 1, right? So whenever you times the number by 1, it does not change its value, right? So here I'm not changing, I'm not adding or removing anything. So I'm just timing it by the same number, whatever I have at the denominator on both sides, the numerator and denominator, because I'm not changing anything, right? However, at the bottom, what we end up having is you then have root 5 times root 5, and then here at the top we have root 5. And we've said whenever you are timing the surd by itself, whenever you times the surd by itself, you will always have an integer, or you always have a natural number, right? A natural number. Why? Because this 5 times 5, we know it's 25, and 25 is a perfect square. So square root of 25 will always give you 5, right? Positive 5. So that way, when our final answer just becomes root 5 on 5. So remember, the question was to rationalize the denominator. So this is how you rationalize the denominator whenever you have a single number. So remember, a surd times by itself will always give you a natural number, right? A surd times by itself will always give you a natural number. Now let's look at the second example, which is kind of different, a little bit different from the first one. However, there's not much we do, because here the question is to rationalize the denominator. So we are interested on whatever surd we have at the bottom. So the third part that we have at the bottom is this square root of 5, right? So this is the interesting part that we need. And once you have identified that, what you do then is I'm gonna copy this again and have 5. Because we're interested in 5, then you're gonna times by root 5. So when you do this again, as I mentioned at the beginning, so this does not change the value. It's just 1 because it's a number over itself. It will always give you 1, right? So and however, at the bottom, what you then have is you have 4 times root 5 times root 5. And then at the top, you have 5 root 2 times by root 5, right? So here, what happens then? What happens is at the bottom, you're gonna end up with at the bottom you're gonna end up with 4 times 5, and then here at the top you have 5 root 10, right? So 5 root 10. Now, what is that? This is just a simple 5 root 10 over 20. But then is that my final answer? No, I can simplify further, right? I can simplify further. The way I would simplify further is we know that 5 goes 4 times into 20, so you end up with 10 with 4, right? That's our final answer. So as you can see, guys, there's not much, just understanding the procedure, right? The procedure is to identify the third part. The third part that we have here is 4, right? And why? Because there's multiplication here. There was a number, but there was a multiplication that whenever you have a multiplication and a third, then you don't do much. You are only interested, you only focus on the third part. which was 5, and then we times by root 5 on 5 root 5 because it's always 1. And then when you do that, however, at the bottom, when you times these two number, you always end up with a natural number, which is 5. And so we had the root 5 root 10 over 20, and then you have to simplify that to live in the simplest form. You get that. And our final example is just this, right? So with this, there's one thing that I have to mention here. Here there was a multiplication, however here there is addition, right? With addition, what do we do? For addition, things become a little bit different, and it's interesting and kind of a little bit hard for many students. So what you do is you have to analyze the sign that we have here. So you have got plus, right? So to rationalize this, you're gonna copy this 1 plus root 2, and then you times it by 1 minus root 2 over 1 minus 2. Why is this? This expression that what I just did here, this expression they call conjugate, right? A conjugate of this expression, a conjugate of 1 plus root 2 is 1 minus root 2. So a conjugate in mathematics is just a relation, is just a joined reciprocal relationship. A joined reciprocal relation, right? A joined reciprocal relation. Reciprocal means like basically saying opposite of this sign. If it was minus, here we have plus, right? And you do the same on both sides because this top part numerator over this denominator will always give you 1. So we are not changing the value. Now, what you do then is you have 2 times 1 minus root 2. And then here you have over this 1 plus root 3 times 1 minus root 3. And then on my next line, what I'm going to have here is you expand the top, which is 2 minus 2 root 2. And at the bottom, now you have to expand that. So if you don't know how to do this, watch my previous video. I think we have done something like this, right? So what you do is you have 1 times 1, 1 squared. 1 times negative 2 is root 2. Root 2 times 1 is plus root 2. And you then have minus root 2 squared. Right, squared. So on my next line here, at the top I'm still having 2 root 2 over. However, here this is 1. 1 squared is 1, and this minus and plus will cancel. And then here, what is root 2 squared? Root 2 squared is just 2, right? Root 2 squared is just 2 minus 2, right? Minus 2. And what is the final answer? Then the final answer is just 2 minus 2 root 2 over negative 1, right? And how can you fix that? I wouldn't leave like that. What I will do for the final answer, what we'll do, I will just have, so that will become negative here, and then have 2 minus 2 root 2, which you can then have minus 2 outside, and then have 1 plus 1 plus root 2. So this is the final solution. Let me explain this again. So we looked at the sign here. The third part is root 2, but because there is plus here, so we have to take into consideration the 1 as well. And what you do, you then take this whole denominator and find the conjugate expression for it. The conjugate expression for that is 1. If it's plus, you have minus. That's what we did here. We times by minus 1 minus root 2 over 1 minus root 2. And then on the next line, you times the top with the numerators, and then that's what we got. And then we times the denominator. We had this. The next line, I expanded the numerator, and after that, I expand the denominator as well. And this is what we had. And after that, after evaluating this, we end up with 1 minus 2, and at the top we had the 2 minus 2 root 2. And that's what we got there. But then I didn't want to leave the negative because it just divide by 1, right? took the negative at the front because I'm dividing by 1, and then I had just go back, reverse this order, taking 2 outside and leave the negative outside, and then this becomes 1, and then instead of plus it becomes instead of negative it becomes plus, because when you expand this you're gonna have negative 2 minus 2 root 3. All right, thank you so much, guys. I really appreciate your support. Like, share, comment, and remember to subscribe to our channel if you haven't done so for more video. Thank you so much.